Okay, we're recording this. It's recording now. Cool. Super. So, good morning, everyone. Good evening. So, the final piece that I'm going to talk to you about today. And again, you know, I must thank this organisation here. You've seen that label before. It is the Engineering and Physical Sciences Research Council. So this work was funded, actually some of the early work was funded by something called the High Value Manufacturing Catapult at the University of Warwick in my department. So the large organisation, and what it's there for is to translate research out of universities and make sure it makes a difference to industry. So I started doing some work called protecting data in the supply chain, and then built upon that, one of the main things I'm going to talk about today is a project called responsive additive manufacturing against natural and adversarial attacks. Okay, so this work I should thank my associate professor Gregory Epifaniou and Mahendra Kumar, who's one of my research fellows, been with me for quite some time now. So first of all, the Internet of Things, you've heard many times, okay? And really we're starting to see it take real shape now. So we've talked for many years about the Internet of Things. Cisco predicted, you know, tens of billions of devices would be in place by 2020 or so, and that didn't quite happen. But now we really are seeing this proliferation of sensorized environments. What's important to think about with the Internet of Things, and it's interesting because how do we define things? We now have all sorts of things. I've seen Internet of Battle things, Internet of military things, Internet of medical things, yeah? But these things, whichever area, so we can see here some of the application areas. So you've got building and construction, with all these sort of use cases, energy, health and life sciences, industrial, transport and logistics, retail, security and public safety, and ICT, and that is consumer and home. Okay. So actually, this work on consumer and home has been really important in the UK. And what we've done is we've created a guide, and now it's a law on how we handle the security of what's called consumer IoT. So that is the kind of thing that you have at home, right? So if you have a baby monitor, people have had baby monitors connected to the internet, right? So they can see, maybe there's a babysitter at home and they trust the babysitter, but what they want to do is see the monitoring of the baby cam. So I don't know if you remember, but there was a Mirai botnet. Does anyone remember that case? Yeah. Okay. And that accessed loads of cameras. Do you remember lots of people having cameras, all kinds of peripherals, printers, all exposed? So we've got some guidelines now on how we protect those. So 3 of the things that made it into law. So I was involved in this work early on through 2 different routes. But what happened is we put together a set of guidelines, and 3 areas made it into law. Yeah. So one thing is now, if you sell consumer IoT in the UK, that could be a child's teddy with something, yeah, you must have no default password. And that was the big thing that you've got before, because default passwords, you could just search the internet, yeah? Does anyone know the search tool that you could search for devices on the internet? Shodan, anyone heard of that? That's a search engine. You could search for peripherals. You could look for printers and things like that. Yeah. So people could. The problem was, if people did that, they knew which model, because of course the device needs to communicate what model it is, what operating system, etc. They could then try and type in the default password. So now in the UK, no consumer IoT is allowed a default password. Every device that is sold in the UK must come with what's called a vulnerability disclosure policy. So if anybody finds a problem, you have to have a route to report it. Yeah, that's a legal requirement. Not all do, but it's a legal requirement. And finally, anybody who sells anything that's consumer IoT has to put on how long they will give security updates for. Yeah. In the UK, we are now working on enterprise IoT. We're looking at ways, what the rules should be for enterprise IoT. So that IoT that goes into your workplace, yeah? And the reason is, so this world of IoT is really useful to us, okay? And it's powered by a range of different advances, yeah? So as you can imagine, what we're seeing is advances in, first of all, connectivity. Oh. So you've got advances in connectivity. So generally now, we're starting to move. 5G is quite well embedded in many parts of the world, yeah? And we're starting on the standards for 6G, but we're really getting good coverage now. So we're getting connectivity with high throughput. For much of the world of IoT, it's not all about high bandwidth kind of things that we need for our entertainment. Sometimes it will be videos, but more it's signals processed at the edge and then transmitted. But connectivity has really helped us advance this. We've got increased automation and AI, so that's helping change the IoT world. And finally, we have to think that the climate is a driver, okay? So what we are doing is we're getting much more just-in-time manufacture, so we don't waste resources, we don't waste energy, yeah? And it means the more we can be predictive about scheduling, yeah, the more we can balance for energy as well, okay? So what is happening is we are seeing changes in efficiency and productivity, okay? We're getting much more tailored and bespoke, yeah? So actually, has anyone heard of a guy, one of the richest guys in the world called Ortega? Anyone heard of that? There is a fashion brand called Zara in the UK. Do you know this? Yeah? Okay, so this guy is very, very rich, right? And you think, how is he so rich? You know, because he's got this nice fashion that in the UK is not too expensive. But one of the things is he really turned around manufacturing of clothes, right? Because he started to use much more data in what he did. So actually, he's actually trimmed out a lot of wastage. So what they do at Zara and other companies is they will look at orders, see what works, yeah, use that, and then get a very rapid, tightly knit supply chain. And that's what we're going to talk about today, supply chains, yeah. So they get these supply chains that are really tightly knit, which means you can have fast turnaround. You can be very reactive. So Zara also looks at what's being sold elsewhere. So others like Boohoo will do some of that now, but it's a fantastic success story because it's driven by productivity. And while it's not tailored, yeah, I guess Shein is the new thing. Have you heard of Shein? Yeah. But what they're doing is being very reactive to demand, okay? So you've got this very quick supply chain turnaround. You've got bespoke things where you can just modify little things. So one of the famous people who did bespoke things was Dell. Dell Computers, actually Michael Dell, what he did is he said, let you choose and we'll build it for you at that time. But it's all built out of components, right? So this kind of thing where you can build bespoke, and I'll talk about what area where that really happens is important. The other thing is, if you want to drive efficiency and productivity, it's also about predictive maintenance. How can we use the IoT and understand what's going on across? So we're getting this very connected world, yeah? And it's been supported by lots of new technologies, yeah? And I think somebody said the other day, one of the biggest is cloud computing. It's really helped us. The interesting thing, let's go back to where cloud computing really took off. What was really interesting, you know, your cloud provider that really changed the game. Well, which company do you think it was that really changed the game in cloud computing? There are only 5 massive companies in the world or so. So who do you think really changed cloud computing? Exactly. Imagine that, right? Imagine that, right? Amazon Web Services, Amazon, which was a bookseller, right? There's still interviews on the web of Jeff Bezos when he's losing money after money after money, and they're going, how come your share is increasing? Yeah. And he was just selling books then, and you were like, I remember people, my contemporaries, lecturers at university, were saying, here is a bad example of what to do. You know, this guy thinks, you know, everyone's going to want books, you know, and it just isn't the case. People want to see a book, they want to feel. But of course, he changed the way that things are going. And do you know the reason that he changed, how he did the change? Well, what it was he started moving it from books. Books also are a little seasonal. People buy a book at Christmas, yeah, in the UK, and it'll be other festivals elsewhere around the world. But people buy a book, and then he started selling a few other things. And what he realized is, I've got these big demands, yeah, these big peaks in demand, but how do I satisfy that? And what he thought is, well, lots of other time I've got no demand at all. Why don't I sell that resource? I'll buy some resource and sell it. And now, the fact that we've got elastic resource, yeah, we can have it whenever we want, that's really powered a massive change. So the cloud really has changed us, but also, so is this. Mobile devices, the things that we can do on the mobile, and the things that we can do that are trustworthy on the mobile, yeah? We've got much better at data analytics now. We're starting to see, it's not quite there, virtual and augmented reality, yeah? Coca-Cola has spent a lot of money on a digital twin with a visual aspect to it to help productivity. Cybersecurity improvements. You've heard about blockchain already of Somanath, and of course, as I said, the Internet of Things. So what we're moving towards is smarter supply chains. So I think it was about 2016, I did my first project on security and privacy in smart supply chains, yeah? And what we were doing is, you've all heard of Costa Coffee, yeah? Yeah, so Costa Coffee has some franchises, and Costa Coffee has machines that you can put into a garage or something else like that, yeah? And what they did is, they have to make sure that Costa Coffee goes out to all of these sort of vending machines, you know, it's hot coffee machines. And they had a very good system for predicting demand. And what they were doing is feeding that into their logistics and feeding it to their suppliers, yeah? Because Costa isn't just about coffee, but you've got to get the coffee in, you know. They don't brew their own coffee, right? They have to go to coffee growers and that, and they have a whole supply chain. But right at the end, what they're doing is they've got this machine, yeah? And they don't, those machines can't run out of coffee, because then people start going somewhere else, right? And also those machines, because they're a small factor, yeah, you can't have infinite amount of coffee there. So what you have to do is predict. And they were predicting, so it was supported by a company that had some data analytics and data connectivity kind of thing. So what happened in that process was they were connecting to their suppliers directly, because what you don't want is somebody at Costa having to analyze this data and say, oh, go and order some more coffee for that one, right? That's far too slow. What you need to do is get the demand signal direct to the supplier. So that's what they wanted to do. But the problem is, that means you've got connectivity into your machines, your endpoints. You've got connectivity that goes into some server that you have, that Costa has, and then that has to have a signal communication, right? And it can't be one way, because you don't want to just say, I'll fire out and say, send me some coffee or some creamer, yeah? Because you need to know if it's coming. So it needs to be a two-way connection. So this leads to potential security issues, and it also leads to potential issues about commercially sensitive data. Not so much in the coffee, but what you want to know is if we have this new thing called dynamic pricing. You heard of that? Yeah? Have any of you experienced dynamic pricing ever? If you have, tell me where.
In the train ticket system.
Exactly, that's the one. Transport is the best example, right? Airfares, yeah? They look at demand signals and then set the price, yeah? It used to be, maybe it used to be, prices might go up, closer you get, and it was just formulaic. And then when you got really close, prices might come down because they're told. Now it's very intelligent, right? So this means we're getting much more connectivity in the supply chain, and it actually drives efficiency in a way, right? Because a train is a good example of what happens, right? So a train station, you don't want your train empty, yeah? But sometimes it's not so good for us because you end up paying more than others. It's a difficult situation. But one thing I'm going to talk about in particular in this talk is so we're getting smarter supply chains, yeah, and it helps us. This supply chain actually is really useful because it connects the warehouse as well. So you may not.
If I want to optimize the cost supply chain, how is it possible?
Okay, so the first question is, who do you want to optimize? You want to lower the cost of getting from the source to the end consumer, right?
Yeah.
Because that's one of the things, right? So I can tell you this. So what you want to think of, if you've got this pen, there's a question, what do you want to optimize? Because the seller of this pen, yeah, wants to make the cost as low as possible from where they pay to where they receive, right? So you want to make it as low as possible from the transition that you buy it, yeah? You want it to be low price, but it doesn't necessarily mean low cost. Because if I buy something in, am I incentivized to lower the cost there? You might lower the cost further down the supply chain, but that benefit might not be passed on to me, right? So what typically happens is you care about the cost from where you have it to getting it to its endpoint. You see what I mean? You've got, if I sell something, yeah, let's say I sell this Pepsi, right? Okay, so if I sell this Pepsi, what I care about as Pepsi is they care about producing this liquid, because that's what they produce, yeah? Let's say they buy the bottle, yeah? And then they ship it to distributors, etc., and it goes down the line. What Pepsi are interested in is trying to lower the cost, probably all the way to the customer, yeah? because if it's expensive anywhere else, it's bad for them. But what they're not as bothered about is the cost of limiting the cost of the plastic bottle. Yeah, they want to reduce the price to them, but not the cost, because if the cost is lowered, it might just be bigger profits for the thing, right? So first of all, you have to define which bits are you in control of and which bits can you benefit from. And what you do is you run data analytics on all the data that you've got. Yeah. So a way to optimize costs is, imagine my logistics. That's where you'll save money on producing that. Your logistics. What you are doing is you look at all of the demand signals and you want not to run out of bottles at the end point where the customer buys, right? Or at the collection point where there's a warehouse, right? So what you want to do is you want to lower those. Yeah, so you've got to define your parameters, but what you do is at any point you want a mix between maximum stock. You need a maximum level, because if you put everything there, it'll get old and that. At least you don't have to keep driving it, but might not taste as good as when it's new, right? So you also, if you put everything at the end point, there's a storage cost. And storage is a lot cheaper normally when you have it in a big warehouse, yeah? So what this is called a multi-objective optimization problem, yeah? So you've got different objectives, which are what space have you got?
You are telling me in case of mathematical concept, but I want to ask you during this supply chain in IoT, Internet of Things, using Internet of Things.
Yeah.
How will I optimize?
So what you do is you need to, so it's all about data to optimize, right? So what you need is to collect in data, yeah, and then run an optimization algorithm. There are optimization algorithms that will optimize, but you need to decide optimize for what, yeah? So your primary thing will be cost, you said, okay? But you will have constraints on other things. So what you're doing is you run simulations. To run, yeah. So you have to estimate what the demand will be at any time and say, how can I make sure I satisfy that?
Every source to destination, all. Every source to destination, if I want to go from this location to this location.
Yeah.
In this location, I want to optimize the cost.
I'm not following your question, sorry.
Locally optimize or globally optimize? What happens? It is locally optimized.
Okay. You would typically globally optimize, but with local constraints is the answer. You have local constraints where you say, I need this minimum requirement, but you globally optimize. You're not incentivized to locally optimize, really, yeah? You should be as much as you're in control of, okay? So, but I'm going to talk about something. Anybody know what additive manufacturing is? No? I guarantee you've all heard of an example of it, because has anyone ever heard of a 3D printer? That is exactly additive manufacturing, because the way that you're manufacturing is you build a layer and you add on, again, another layer. So even if it is a single fabric printer, yeah, so it's just a plastic printer, for example, yeah, then you adding layers on, that is additive manufacturing. But typically when we say additive manufacturing, we mean additive layer manufacturing, actually, ALM. And what that means is where you build something, you put a layer down, and then you have something else that you put a layer on top of, so a different material, okay? That is additive layer manufacturing. And this can work in a single factory with multiple machines. So what you do is you've got a machine, you do some layering, yeah, some sintering or something. It goes to the next conveyor, and then something else goes on. But actually, you can, and it's a strange word, 3D print, but you can 3D print a house. Now, if you just look on the internet, there's plenty of examples. So these concrete mixers and the 3D print a house, okay? So you can do big things, is what I'm saying. And you can do things for military purposes, yeah? Now, what happens is when we do additive manufacturing on some complex devices, what we tend to do, and this is about efficiency now, what we tend to do is instead of having all these machines, imagine there's 5 different processes with different materials, instead of having all those 5 in a location and then 5 in another location, so exactly the same replicated in multiple geographical locations, what we do, because these machines can be expensive, we actually move the parts, yeah? And actually in the UK, I don't know about, well, in Europe, I don't know about in India, but cars have got different parts built, not with additive layer, but they've got different parts built in different parts of Europe, yeah? Depending on what the speciality is. So maybe all of the, you know, the key components of the engine are produced in Germany, constructed in Germany. The panels of the body of the car might be in Prague, in Czech Republic, yeah? So they do this, so you've just got a specialist facility, and what they do is they then move the parts around, and then you have one assembly point, yeah? So this is a very common kind of approach of distributed manufacture, yeah? But actually, now you can do the same with additive layer manufacturing, right? So you build some things and it follows a process, yeah, to build the element. So we are looking at additive layer manufacturing, or we finished this project in September. It was worth just over £1 million, yeah. So that's what, 100 million rupees or so. Okay, and we had to make sure that the supply chain was secure. So what I'm going to talk to you first, again, some guidance. There's 2 organisations I'm going to show you some guidance from. First one is an NCSC in the UK, and it's got the 5 steps to supply chain security, and we use some of these steps in our process. So what you need to do is you need to understand what is important with cybersecurity. So how do we understand what are the negative consequences? Well, we use threat modeling, okay? And what threat modeling technique did I teach you this week? 2 components. One was about the impact and one was about the kind of threats. Stride and dread. And dread, okay? And stride was spoofing. Anything else? Spoofing?
Spoofing, tampering.
Tampering, yeah.
And information disclosure.
Repudiation.
Yeah, repudiation.
Information disclosure.
Yeah,
correct.
Yeah.
And
elevation of.
Yeah, elevation or escalation of privacy. Very good. Okay. And also looking at looking at dread for the impact to see what damage, etc. there was. Okay. So you develop your approach. So you prioritize. So you're seeing these words. Have you heard the word crown jewels analysis before? So anybody in cybersecurity needs to think about that word, crown jewels analysis. What's the thing you most want to keep? Yeah. Create security profiles that you can analyze, assign to each supplier. So think about your supplier, think about where your risks are. Let me tell you, security in the supply chain is really difficult, yeah? Because I imagine that you sell me something, right? So what I can do is say, I want these products, yeah? But I know that especially in a world of IoT, we're connected. Anything that you're compromised, yeah, can have an impact on me, and it could be without the human in the loop. Remember what I said about Costa? You don't want to be typing in saying, can we have some more to that site? It's automated, yeah? So what we have to do is I need to trust your security. How can I do that? How can I see your secure practices? I can ask you for some information. Are you ISO 27001? Yeah, I can do some things. But what becomes difficult is you have also got a supplier down the road. So actually, the vulnerability of an offender that feeds you, that feeds me, is a vulnerability that I have of a higher order. So we need to assign profiles, but it's difficult. We apply that approach to any new supplier. So what we say is, if you're coming on board, these are the requirements, okay? So I'm going to give you an example, and it isn't in the exam, but I really encourage you to remember this. And it's an interesting area now if you're looking at propagation of threats. So you can model that mathematically, and it's quite a nice, interesting problem. But in the US, Joe Biden issued an executive order, and it was one of the executive orders that Trump hasn't overturned, but it was a requirement that if you sell something, some software to the US government, you must sell that with a software bill of materials. So if I sell a piece of software, I have to tell the US government every bits of library and code that are in there. And the reason for that is because we've had problems with Heartbleed and SolarWinds and other kinds of things. If you know all of the bits that go in, if there is a CVE, a vulnerability that's disclosed, I can see, because I know what is inside my sort of box. So it's not like AI where you don't know the model. You don't know the model, okay, but I know the libraries that went in, yeah? So if there is a vulnerability reported, I can do that. So that's one way that the US government have said, new supplier relationships, you all need SBOM. If you don't have the bill of materials, you cannot trade with the US, you cannot supply them. Integrate the approach into contracts. So remember, I told you there are socio-legal things. Remember I talked about data trusts, where what you do is you say, right, there's going to be some accountability, was the word that we talked about. And you say, right, I'm going to sue you if you do something wrong. Yeah, put that into contracts, because that will help people think, if I do this wrong, I will get sued. Yeah, so put the approach into contracts and then monitor and continuously improve. So that's the NCSC guidance. We've also got guidance from the other authority I told you about. Oh no, this is from NCSC as well, sorry. But they've worked with, this is important, can you see they've worked with NPSA? Yeah, because they recognize supply chains, there's a physical element too, right? So this is another piece of, another document, which is about the understanding the principles, yeah? And the one thing is, so communication between the supply chain is really important, yeah? And what you should do is you have some responsibility to raise awareness within your supply chain. So what you've got to do is communicate them and continually tell your suppliers what you need, yeah? It's trying to give double responsibility, right? It's trying to give you, if you are typically in the supply chain right now, many of the people in the supply chain have got, they have supplies that come in themselves and they supply to someone else, yeah? So they ingest data and goods and then they export, yeah? So what they're really trying to do is say, look at your responsibilities both as a supplier and a consumer. Okay, so this is this additive manufacturing, right? So we start with a computer-aided design model, yeah? And then you get this file, which is called an STL file, yeah? So I'm sure some of you have done some 3D modeling before. There's lots of CAD model systems around. But what you get from that is a file, and it's just got all of the data points that you've got. You then send that to some computer-aided manufacture software. So that works out. How do I do the manufacture of this? How do I send this to different places? Yeah. So it's not the design. Now this is the 3D shape. Yeah. This, what you can see here, if you look at these diagrams, actually, this is the CAD model of a sort of flower pot kind of thing. I don't know what the device was we were manufacturing, but you've got that. So you get this STL file, which is like a 3D mesh. Yeah. It just tells you what the geometry of the shape is. Yeah. The CAM software turns that into a toolpath. So if you can see here, you've got the different layers that it's saying, yeah? And actually, a sophisticated CAM piece of software, yeah, could put that into different manufacturers. The toolpath command file goes to a 3D printer, which you take some material in, and there you go, there's the completed part, and you'll do some quality control. So that's the standard 3D printing process. Okay, so now we've got to think about additive manufacture with supply chains. What's the vulnerabilities? Yeah. So what you can have is the digital file, yeah, could be manipulated. Somebody changes that, yeah. So if somebody changes that, in fact, you can change either of those, but somebody changes the digital file and you end up with a piece that's not correct. Intellectual property, somebody could steal your intellectual property, or you can have vulnerabilities in the operational process. You can have data theft, people can sabotage. So this is one thing that's important. In fact, these two are really what drove us to this project. So first of all, there is an organisation in the UK called Lloyd's Register Foundation. And what they did, they examined the some maritime goods, some marine goods, yeah. It was for the Navy in the UK, yeah. And they were examining weapons for military purposes in the Navy, yeah. And they found that lots of the materials, lots of the, well, in this case, weapons that had been produced had got counterfeit elements within it. Because, you know, it was that distributed manufacture. It wasn't additive layer, but it was distributed manufacture. So what happens sometimes is people, yeah, instead of putting a genuine part in, they create their own part, yeah? And they put that in and they think it's okay because it's going into, you know, some big gun on a ship or something like that, yeah? So they think, well, if I've got this little bit and it's not the true genuine part, it's okay, right? I've got a cheaper alternative. So this product counterfeiting is something that happens quite a bit, yeah? So what you've got to do is make sure that the product that you've put out that you want to 3D print is actually the product that is printed. The other thing is, because of where we were looking in sort of military context, sabotage is possible as well. So people try to corrupt. So these are the kind of cyber threats that we were looking at, okay? And also, I should say on that counterfeiting, there's also a counterfeiting where somebody steals the design, yeah, and then replicates it themselves. So you've got to make sure that, you know, the designs are properly, you need some key management, right? So that only the right people can understand the process. So here's all the points that we looked at where the attacker could go in. So getting unauthorized access to just about any point, modifying the final part, yeah. So this is one place, accessing the 3D printer, etc. Okay, so we have already seen, yeah, these kind of problems. So these Anycubic 3D printers have been hacked worldwide. So that's a big company selling 3D printers. This is one thing that we were concerned about, yeah. Military 3D printing systems, yeah? So I think many of you in this room wouldn't have realized that you'd have 3D printing in military bases, right? The one thing here is that this organization, the Advanced Manufacturing Training Center, yeah, has had to double capacity in cybersecurity training. So this is the project. It ran for about, what's that, nearly 3 years, 30 months, I think it was. Yeah. Now look at this. Do you recognize this? Anybody recognize that? This is a version of the cyber resilience that I said, right? The CIRES methodology. What was the CIRES methodology? There were 3 parts. I'll tell you the first one because it's the same as here. It was detect, understand. Very good. Same process. You want resilience, yeah? So what we had is resilience, and for this, because we're working with others and you have to get the right language for them, what we said is detect, analyze, and respond. So we work with people at the University of Surrey and the University of Bristol in the UK, and you can see the kind of partners were security partners, aerospace partners, and a bunch of others. And Thales are a big defense company. Yeah. So what we were doing is the first thing we were trying to do is additive manufacturing with integrity and authenticity, right? So what we were doing is, so the first thing is creating physical hashes for objects. Yeah. Once we got the physical hash, so this is a true physical hash. This means, you know, we talk about hashing of digital artifacts. Yeah, the guy who was the PI, this Greg Gibbons, there are some great ways that you can detect, and we've got a new project in this area, is this, you can take a fingerprint, if you will, off any kind of device. So it's really important to try and get the right fingerprint so that it's unique. You've got to be able to capture it off something. But the idea is, what you need to do is, if I'm going to take this and then use that part in something else, what I need to make sure is that this thing is what arrives at the next destination, right? So what I need to do is have a hash. I need to have some way to say that this is precisely this, so it's non-fungible, yeah? So I need to have a way to do that, and people in who do additive manufacturing can do this. So what they want to do is they want to encode physical hashes of a bottle, yeah? Then what they want to do is detect the unique fingerprint, yeah? And they capture that. So what we do then, this is our bit where what we were doing. So you've got a manufacturing specification parameters. We're going to give threat information out to the people at Surrey and Bristol, yeah? So what we had to do is we had to do something called a physical to digital cryptographic anchor. So there's another word for this anchoring, and I've mentioned it this week already. It's called binding. Yeah. So what you have to think is just the same as with ADHAR, that foundational system. Remember, I told you ADHAR, all it does is it binds the person in front of me to a number, so I know who you are. Yeah. And the way we do that is you present your biometric, and I've already stored your biometric. I get the biometrics the same and say you are the person that was in my database. Now we do the same principle, yeah? We do the same principle. Oh. Okay. We do the same principle by taking some measurement of this. So we've got a new actually project proposal that we've got, which actually, to give you an example of how you can do this, you can shine light, certain light at a certain angle on this device, yeah? And it's not disrupted by scratches too much or anything, but you shine it off and it gives a pattern of light. It's called a speckle pattern. So we think, oh, right, if you put that at that angle, I can tell if it's that phone that's ended up somewhere else, right? So we get these physical hashes, yeah? And what we have to do is bind them together, okay? So that's the first thing, yeah? So we have these these hashes, and we put them on a private permissioned blockchain, yeah? So you've heard of blockchain this week. You've got public and private, and you've got permissioned and permissionless, yeah? So what we do is we then have a threat cost impact visualizer. So what we do is we say, well, what? So first of all, get that. Secondly, we've got this network. We say, well, what are the threats? How can we analyze the threats? What happens if there is some spoofing or tampering, etc.? And what we do then is finally, we create something called a threat information exchange. So some of you may have heard of STIX and Taxi. These are formats that we can exchange threat information. And what we then do is, with all this information, these guys are, he's just left, but these guys do the optimization. Yeah, so they will optimize not only for cost, but also for risk. Yeah, so what happens is, if I've got a supply chain, yeah, and I've got a device, so let's say I need to do something else to this, there's some finishing. I may have 2 or 3 different suppliers who could do the next thing that I can pass it to. What we do is the threat information will say this one has been compromised, or this one is likely to be compromised, increased risk. And that means that the optimization now doesn't just consider cost, but they re-optimize based upon the threat and the other parameters that are important. So cost, time, etc. Yeah. So that's what the Bristol guys did. So that was the project. So what we were having to do is ensure the integrity and authenticity of physical objects to prevent tampering and unauthorized access. Yeah. We created a tool that quantified the cost and risk exposure if there was a disruption. Yeah. We also detected and accurately quantified threats. That helped us to consider that. And we created this secure exchange. And in fact, at the end, I'll show you there's a lot of papers that we generated out of this. So, as I said, we need to link or bind the physical objects to their digital counterpart and create the structures so that you can do management and verification along the line. Sorry, I don't know your name, but I was just saying that in this project, yeah, what we did is we did this threat information, and these guys using the threat information we had, yeah, could not only look at the costs, which is one thing because these are supply chain optimization people, they could also look at the threat. And that's why I said it's multi-objective. Sometimes you want to lower the cost, sometimes you want to make sure it gets to the end point in time. But that's what these guys have done in this paper. They're from business schools, not because I'm not from a business school. So this is the whole end-to-end process. One thing you get is you've got a manufacturer, yeah? You get a G code of the digital file. So the G code is the actual code for 3D printing, yeah? Okay, we put that into a smart contract, but we also take at the same time a physical fingerprint of the device, yeah? And what we're doing is on this permissioned blockchain, private permission blockchain, this is handling the physical, which is the dark things, and the digital, which is the lighter elements, yeah? So all this side is sort of digital, yeah? And this side is the physical, yeah? So what we do is, as I said, we start with this crypto anchor, this binding, yeah? So it's based upon both the G code, which is the digital file, and the physical fingerprint, okay? We verify the authenticity of something. So when you receive something, we verify it. And the way we verify it is we go to the blockchain and say, oh, I've just received this. So I go to the blockchain and I say, well, was this the thing that was sent to me? Yes, it was. And then I say, well, hang on, also let me see that the digital file is the same, so I can check that we've got the right digital file, okay? So that verifies across making sure, because that the project hasn't been tampered, the physical thing, and corresponds to the original G code. Then we distribute the G code across distributed off-chain storage. So we create a tag, yeah? So we use a composite of on-chain and off-chain. We have an audit to check the accuracy and consistency across all the G files, yeah? And then we can retrieve and download the data files from the distribution storage whenever needed. This gives us a sort of auditability, yeah? So we've got reliability, security, and trustworthiness, but here is auditability that we can retrieve at any point. 15 minutes, yeah. Okay. So what we do is we created a cost impact visualizer and risk exposure. So what we do is you've got a set of databases. So this process actually can be used for any. This is around cyber threat intelligence. And what I've tried to do is show how things come together across all of the talks that I've given, right? Where have you seen something that has got cyber threat intelligence collection or sharing? What have I taught you about this week where I say gather intelligence of cyber threats? It's a key component in the zero trust architecture, right? So you'll see how zero trust, this isn't a zero trust architecture, by the way, necessarily, but how zero trust collects important elements and brings them together. So if you've got a zero trust architecture, you're really taking some of the best concepts from security, right? So you're looking at security from a context point of view. You're looking at security that understands the local and the wider context. So what this is, you see, is taking a number of different databases and collecting that threat intelligence. So the tools that I've mentioned before to do that, for example, are MIS. Yeah, and MIS is for information sharing. Yeah, it's a malware information sharing platform. Yeah, and it pulls in information from Twitter, from Google, from different RSS feeds. Yeah, RSS feeds. It reads in from CVEs. Yeah, etc. So you have this CTI collection, which is from a set of databases. These databases might be a sort of federation, in a sense, right? Where we're getting some federated analytics of this CTI. And so therefore we might put some privacy in here. And in fact, if I just look quickly, I haven't got the papers on here. Sorry, I'll just start again. Slideshow. I can send you a link to the papers. Sorry, I thought I'd put it on. But when we've done, because actually Mahendra Kumar is a cryptographer, this bit you can actually do, you can use private set intersection, you can use some secure aggregation of stuff. But what you can do is these can be open or closed. So they can be open public sets, but you can also share CTI from sources where there's commercially sensitive information. So we have all of that. We then feed that into a threat intelligence knowledge graph. So we try to see the interdependencies between all of those levels. So we did this work quite a long time ago, but knowledge graphs now have just gone through the roof, right? Everyone's using knowledge graphs. From that knowledge graph, we create we define the features to create a metagraph construction. We then have some learning on these graphs, and that gives us an opportunity to do threat prioritization. So this is the process starting from distributed data through knowledge graphs and features and a representation in this graph, yeah, that allows us to give some threat prioritization. I mentioned, I think yesterday, something called IOCs, yeah, indicators of compromise. So they're your priority areas that if you get this indicator, that one is very important, right? Because it's come through the collection. So you found out from these distributed data sources, ultimately through this process, you're trying to say which is the most important indicator of compromise. And then you can say, this is the one I'm looking for most closely, or if I see this, I've got to act most drastically. Yeah, so our system is secure and efficient. So we've got a few parameters. It's got to be real time. Yeah, and you can see here, here's a set of devices. We encrypt the data. So we use an encryption scheme here to our central threat information broker. Yeah, we look at the similarity. Yeah. Now, the good thing is we can do that in the encrypted domain using homomorphic encryption, yeah? And what we can do is we can check against the private blockchain the integrity at all points, okay? So, and this that we send out, this SPM sectors, is where you're getting the, these are the people that sign up. So these are your suppliers within the system, yeah? So let me, so what we do in this is we unify threat-related information. So the standard for that is this threat information, standardized threat information exchange. So STIX is what we use. We then have TAXI is an information exchange protocol for threat information exchange. So we use TAXI to automatically share that information with others, enabling intelligent information to be exchanged more quickly. What it means is you don't have to do what's called data wrangling then, okay? Because the data is all standardized so it can be understood. We then integrate that into the blockchain, mainly because of accountability and immutability processes. And then what we can do is give these following services. So we can publish cyber threat intelligence. So we can become a publisher that other organizations can put into their own version of this, which may or may not be in additive manufacturing. Yeah, we can check the integrity of the threats, and we can have a subscription model, and people can specifically send queries to our database. So that's our approach that we've done in Ramona to make sure that we get security in the supply chain. So it relies essentially, if we go back to this, the key things that it relies on, are these three things, which is first of all binding. Make sure that the physical object is bound to the digital object. Yeah. Make sure that we understand the risks and create this information exchange so that you've got secure sharing practices across the supply chain. Okay, so that was about 55 minutes, so just under an hour. So I've got 5 minutes left if anyone's got any questions. And in fact, because that's the last session, I'll take questions on absolutely anything that you've got, that you've heard this week.
What kind of information was going there?
What kind of information goes in the STL file? Yeah, okay, so the best way to see what an STL file is here, right? So what an STL file defines is the number of points in 3D space. Yeah? So you've got points in 3D space, and then you've got the relationship between the points. So sometimes it could be a straight line between points, yeah? And other times, like you see here, it's telling you there's a curvature between points. So it's all about, so if you think about, you could do this almost like a graph, yeah? But think of it like a graph, but when we have a graph, we think the connectivity is linear, and all you do is label the graph, yeah? So you would actually have a graph of every point on there is a node in a graph, yeah? And every bit that connects them is a vertex, and you could just label the vertex, for example. But this is a standard file, and I don't know the exact details of that, because this is really from the additive manufacturing folks. So this standard, I haven't got the whole detail of it, but that's the basic principle of it. The CAM software turns it into a toolpath command, which basically says, okay, how do I do it? You know, because actually, even though it's not distributed, what you could have is these bits be in different materials. So it gives you the toolpath. It says, first of all, do this with this layer, and then your next stage is this one. So it tells you the steps to follow. So if you've ever seen people 3D printing on the internet, you'll sometimes have to print it in a certain way because everything needs something to go onto, right? You can't print in mid-air, yeah? Yeah.
Model poisoning and administrative attack comes under the algorithm tree.
Say that again, sorry.
Model poisoning and administrative attacks comes under algorithm tree.
Yeah.
So I have like whenever the attacker has white black box access, is it really possible to attack on the model itself?
Right. So if you've got a black box access, can you poison the model, for example? And the answer is it depends on how it works, right? So very often now, and especially we talk now about continual learning, or you know what had been called sort of more evolutionary learning, right? So it evolves, right? So if you've got a feedback, yeah, and most of the time this happens, right? At federated learning is all about that continuous loop back, right? So what you do is you create a model, you send it down local, and you say how well does it fit, and it goes back, and it's so those loops are why you are disrupting the weights in the model. So it's definitely poisoning the model. Yeah.
And so, also it is possible that attacker or any user will have white box access in real world.
Oh yeah. So this is an important question. Is it possible for the attacker to have white box access?
Yes.
Lots of times, yeah. So first of all, you can use side channel analysis to at least give you some, maybe not complete white box, but there's a bit between, right, where you know some of the architecture. And that might be because it's published, so you might not know all the weights, or you can have some side channels that will tell you some of the weights. But the other thing is, unless, you know, there's always somebody involved. So an insider, yeah, a developer, for example, has always got white box access. Okay, good questions, good questions. Okay, you've handed out these feedback forms?
Yes.
Cool. Okay, well, I will let you complete those feedback forms, and then I think we've got some coffee and tea, have we?
Yeah.
So do you want to fill out the feedback forms first? So I thought you were giving out the exam forms. So what we're going to do is we'll hand out those forms. Please complete those forms now. And then as soon as you finish, just head out for some coffee and tea, and I'll just read the exam, see if I can do it.
We collect that.
Nice and secure. You didn't look at it. Oh, thank you.
आप लोग बाहर चाय रखा है।
वो आपको पास की क्योंकि उसमें डेटा भी पूरा कंप्लीट नहीं है तो वो दूसरा सब वो आपके पास है बाकी ये ठीक सर एग्जाम भी टाइम कर क्या है नहीं नहीं अरे अभी जा
Are you LinkedIn?
Yeah, yeah. Yeah, somebody's request. Yeah. Which university are you from?
I'm from IIT Patna.
Okay. Yeah.
And I will contact.
Super. I look forward to it.
My friend is there in UK. Now he is in USA.
Who is it? Your?
My friend
Oh, okay. And what is your friend doing?
in industry.
Okay. What kind of industry? I'll come out. We'll have a chat. So you can have some coffee. We still have a good few minutes yet. We're not starting just yet. We'll start.